Welcome to this evening's TI Technology webinar hosted by Texas Instruments. We'll take a look at how TI-84 technology can help you transition to working with the TEKS standards. I see that many of you are joining us for the first time, so we'd like to offer a special welcome if this is your first T-Cubed Professional Development webinar. We'd also like to thank everyone for completing the live survey on the right side of your screen. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all students. I'm very happy to introduce our two panelists for tonight, Tony Norrell and Michelle Reinhardt. Tony has over 25 years of teaching experience from 5th grade to college algebra. She is currently a math specialist and a T-Cubed regional instructor. Tony was also a TAE-MST winner in 2007. Thanks for being with us, Tony. And Michelle studied mathematics, physics, and education before moving to Texas. Michelle has taught high school math and science at rural districts in Texas, while also working as a math and science consultant. Her interests include technology integration, conceptual understanding, and curriculum and instruction. Michelle has presented at numerous state and international conferences and was named one of 3 finalists for the 2013 TCEA Texas Teacher of the Year. Thanks for joining us, Michelle.
Thanks, Mike. Glad to be here.
We are expecting a large crowd, so your audio is muted. Feel free to send questions to all panelists using the Q&A window on the right side of your screen. We'll also send general messages in the chat window. Once you move to the software, the right section of your screen will be replaced with a green floating toolbar, and you can access the Q&A window by clicking the question icon. This session is being recorded, and as a reminder, we will provide a link to the event certificate of attendance at the conclusion of the webinar. Once the recording is available, if you'd like to follow along with your handheld or your software, and we really hope you will, we recommend doing this with the recording so you can download the activities and then pause and rewind the recording as necessary. We don't expect you'll have any audio issues tonight, but the event that you do, try selecting Communicate at the very top of the WebEx menu, select Audio Broadcast, and then click Join. At this point, Tony is going to discuss our agenda. Tony, you might be muted.
While Tony's troubleshooting that, I can just kind of jump in here. Tonight we've already kind of done our welcome and introductions, and then we'll start with an overview of the TI-84 Plus, and we'll do that through a couple of activities. So we'll look at how we can do some linear modeling and also a number of different calculations that we would typically do in 8th grade and what those will look like on the 84. And then we'll wrap up by sharing with you a bunch of ready-made activities, and one in particular, and then showing you where you can access those activities on the TI Math website.
Thanks, Michelle. And also, if you wouldn't mind then doing our expected outcomes.
Sure. So our goals for tonight, we're going to learn how the 84 Plus can support transition to the new Texas Essential Knowledge and Skills, so our new standards that are coming. We have picked specific activities that will highlight how the TI-84 can help with a lot of these new algebraic type standards that have moved down to 8th grade in Texas. So we'll be looking at the new TEKS, but we'll be looking at them through the lens of how the TI-84 Plus really supports instruction for those. So we'll look at a number of basic calculations, graphing, functions, scatter plots, all kinds of stuff in tonight's webinar. And then at the end, we'll also share with you a number of ways that you can stay in touch with TI and continue your professional development throughout the summer. So with that, let's go ahead and jump in.
Perfect. And as Michelle is now sharing her desktop, Some of you have already used that chat window, and that's awesome. I know Michelle and Tony are both going to be possibly asking some questions throughout the webinar, and you might need to respond in that chat window. And as you notice, that chat window and Q&A window disappeared. And you can find the chat and Q&A window if you move your mouse underneath that green floating toolbar. There's an icon for the chat window, and the Q&A window is hiding a little bit. It's under the options, the eject looking button. You can click on that and then bring up the Q&A window as well. Michelle, it's all yours.
Good, Mike, thanks. So we welcome you here tonight. I'll be running most of the software, if you will, from my desktop. And Tony and Mike will kind of be overseeing both the chat and the Q&A windows. So we really encourage you to participate through those windows. Feel free to share your questions along the way, your reflections, etc. And then Tony and Mike will really be your voice in this session as well to get those questions addressed. Other things we need to mention before we get started, as Mike mentioned, it may be difficult to follow along if you've got an 84 with you and you're trying to follow along kind of keystroke for keystroke throughout this. That might be a little difficult, but you will have the session recorded. That link will be shared with you, and so you'll be able to go back and revisit that. And also, Mike will share at the end of this session a number of awesome opportunities, intense PD opportunities this summer where you can really dig into the 84 in a 1-day format, 2-day format, 3-day format, and really look at these ideas still aligned to the TEKS, but in a more intense session. So with that, I think we're ready to jump in, and we're going to, as I mentioned, we're going to look at the TI-84 functionality through the lens of a number of different standards from 8th grade math. So here's the first one we're going to start with. I'll give you a minute or so just to kind of read through that standard. It's new to the 8th grade, coming down from Algebra 1, and then we'll look at a question that might be posed for this standard. So we're going to start with some linear modeling and using multiple representations, so graphs and tables and all kinds of things. And we've kind of come up with a little problem situation that we'll start with, and you should be seeing that now on your screen. So why don't you take a minute and just kind of read through this problem to see what we're looking at, and then we'll jump over to the 84 Smart View and look at some ways we could model this. Okay, so a really kind of typical question for linear modeling. And we're going to kind of start from scratch with this, as if this was maybe an explore activity we would do with our students to really build into what is a linear function, how do we model it, how do we come up with an equation for it. So now on my screen, you should be seeing my TI Smart View software for the TI-84 Plus. You'll notice that I do have it on the TI-84 Plus C, or the color option, but I would like to mention that if this is a software that you already have at your school, maybe your high school teachers have it, maybe it's something you already have, you might just have an older version that only has the 84 Plus, but not the 84 Plus C. However, that is a free update that you can download and update your software so you can actually toggle back and forth between these two views within that same software. So I just wanted to mention that because this is a great instructional tool, either teaching in the 84 Plus or the 84 Plus C mode. So here we are, and the first thing I think we're going to do is as a class we might create a table of values. So we may not be able to come up with an equation of this for this right off the bat, but we could probably come up with some values like how long would it take for 1 hour, or how much would it cost for 1 hour of work, or for 2 hours of work, or something like that. So say we've created that table on paper, and now we want to put it into the calculator. So this is maybe one of the kind of hidden aspects of the 84, but once you've done it a couple times, your students have done it a couple times, it'll become a lot more familiar. So to enter a table of data, or to enter some lists of data, we're actually going to go to the Stat menu. So I'll push Stat, and I've got a list of options here, and all I want to do is this very first one, number 1, Edit. So I'll push Enter to go in there. And once I do that, it looks like I have this spreadsheet that I can work in, and really I've got a number of lists where I can enter in some data. So I'm going to start by kind of posing to my class, okay, can we figure out how much it would cost for 1 hour of work then for 2 hours of work, 3 hours of work, 4 hours of work, maybe we'd go as far as 5 hours of work. That would give us kind of a nice set of data points.
Michelle?
Yes, Tony?
What do we do if there's already data in the lists? Is there a way to clear those?
Oh, okay, so that's a great question. So if someone was following along, or if your students were doing this in class, and they went to the screen and there was already something in their L1 or L2. Okay, great question. And this is something that you will come across on a regular basis in the classroom. So there are a number of ways to clear out your list, but one of our favorites, or one of my favorites, is to go up to the top of the list where it says L1, and then you'll push clear. And you may have noticed that when I pushed clear, something disappeared down here. We'll come back to that in a minute. And then, I mean, it didn't clear my entries, but now as I push the down arrow, it will actually clear that list. So that's a lot faster than having to go through and delete or clear every entry in the list. So that's kind of a good shortcut to know. Thanks, Tony, because that does come up a bunch. So I've cleared that list, but I want to take a minute now and re-enter it just to kind of discuss the notation that goes on here as well. So for example, if I move up one cell, you'll see down at the bottom I've got L1 for list 1, and then in parentheses here, this is actually meaning entry number 5. And so my 5th entry actually is equal to 5 because of the data that I've entered, but that's not always the case. I can go over and enter some L2 data here as well. So for example, yes ma'am.
Sometimes my students think they're clearing a list, but they actually delete the entire list, the L1. Could you talk about that for a minute?
Okay, that's a great question too, because, and let me think about the way that some students do this. So, for example, when we went up to L1 to kind of clear out that list, we kind of have two options. We can clear that list, or we can delete that list. So we talked about how if we push clear and then down, it will clear that list. But if I accidentally push delete instead, that entire column has now disappeared. And so maybe I think it's just over to the left, so I push left arrow. But you'll see it's not there. It has been deleted. And that is a common mistake, or kind of a typo, if you will, that students will do, and then they've lost that list or that ability. So there's a number of ways that you can get that back. And one is a little bit more cumbersome. You can actually kind of reset to default, reset your whole calculator. But a way that someone has shown me recently, which I love, is you can actually just insert a list here. And so I'm going to be in L2, the closest to the left that I can be, and I'm going to insert. So right above delete, I've got in blue here, insert. So to do that, I'll do second delete, and then now I have a column that I can give a name to. So it's prompting me for the name down here, and just for consistency's sake, I want to call it L1. So I got to look over all my options over here to see where I could find L1. And in blue, right above the number 1, you'll find L1. So I could actually go second 1. That will bring up the prompt for L1, and now I can push enter to name that column L1. Notice that when I did that, it actually brought back all of my data from before. So I had deleted that list, but it was saved in the memory somewhere. It just wasn't accessible on this page. So, Tony, thank you for sharing that, because I've done that a lot, and my students have done that a lot, and it's good to know how you can kind of come back from that. Thank you. So kind of moving back to our question, if we're figuring out how much it would cost for 1 hour of work. So I think we had like a $12 service fee and then $8 an hour. So here we would type in $20 for 1 hour of work, and then 28, I think, for the next, for 2 hours, et cetera. You could also do calculations here. So if there was a calculation that was a bit more cumbersome, they weren't sure what the computation was, they can actually just type in 28 plus 8, for example. That gave us 36, and then 36 plus 8, et cetera. So it works like a spreadsheet as well. You can kind of use that functionality. I think that's enough data. Go ahead, Tony.
So can we just graph it now with the graph button?
Awesome. So we have our data in, and we want to see these points on our graph. And so we'll see a graph button up here, and we'll go ahead and push the graph button, and nothing magical happens. And so this is one of those times when my kids will tell me, my calculator is broken. And so also, this is one of the other kind of hidden features about how we are entering points. Remember that we had gone to the Stat menu and then into Edit in order to enter our data as points. So this isn't actually turned on yet. We're in the Stat part of the calculator, so we need to turn on a special type of graph called the Stat plot. So on our calculator, we'll see Stat plot here above y equals. So we can go second y equals to view our Stat plot menu. And then we have a number of options, but we'll just go into this very first one, number 1, for plot 1. And I'm just going to pause here and let y'all kind of just check out the screen and look at how things are set up, what it's asking for, and also what our options are here. So we've got on and off. Right now it's off, which is one of the reasons we're not seeing our data. So I'm going to push enter to turn it on. In this next row, you can select the type of graph you want. We're just doing a scatter plot. That'll be our first option, but you can do line graphs, histograms, box and whisker plots, all kinds of stuff with just the touch of a button. Then we're prompted for where are our x values. And we did put our x values in L1. Where are our y values? They are in L2. You can change what the dots look like on the graph. And then with the 84 color, you can actually change the color that the points will come up in, just kind of by arrowing left and right. So I think we're good here. We've kind of got our stat plot turned on now. So if we go back to our graph, which we weren't seeing anything on before, we still don't see our points. So what we may want to consider is what our points were. And back in our, I went to Stat, Edit to go into our points again. Our first point is 1, 20. Going back to our graph, we're actually set up to where this graph is going from -10 over to 10, and then -10 up to +10. So we're not going to see our points with how our window is set up. So let's talk about a number of ways that we can kind of change our window. The easiest way is just to push the window button over here by y equals. And again, take a second and just peruse your options there about what we can change and what we're prompted for here. So we can change this to kind of think about what we want for our situation. So we might say, you know, the lowest number of hours you would ever work is 0. So I might do that as my minimum X value. And then max of 10, sure, I'm fine with that. X scale is going to ask us, well, what do you want your X values to go over by? And going over by 1, that sounds good. Y min, well, again, maybe we'll start at 0. It's not going to cost less than that. And Y max, maybe we'll go up to something like $80. But for our Y scale, I maybe don't want to go by 1s if I'm going from 0 to 80, so maybe I'll go by 5. So this is a really good screen to bring kids to. There are other kind of shortcut screens, but this is a good one because it really has students think about constructing their graph. What do you want to go from and to on the x-axis, and on the y-axis, and what do you want to go over by, just like students would do when they're graphing by hand. So now if I go back to my graph, it looks very different than it did before because we've changed all the settings. Now we're seeing our x-axis as we set it up and our y-axis as we set it up, and there finally are our points from our stat and from our stat plot.
Michelle?
Yes, ma'am.
One of the things that I like to do is maybe use negative values for my x-min and my y-min so that the origin shows and the students can tell that they're actually looking at the first quadrant.
Okay, so like in the window settings, you mean?
Mm-hmm. So,
okay.
So we can see our whole first quadrant, but if we go back and we change our x-min even lower than 0, maybe a -1.
Okay.
And then if we change our y-min to -5.
Okay.
And let's see what that does to it.
I like that. So even though -1 and -5 aren't necessarily going to be applicable to this situation, by going down that far and going over that far, you kind of get a better picture, and you see that this is just going to graph in one of the quadrants, but there's other things going on in the other quadrants. Okay, great. That's a great tip. Okay, so from here we kind of have our data set up, and we want to start modeling this with a function. A number of ways that you can do that, and we're going to explore one or two. We're going to start, though, by starting with maybe the linear parent function, the line y equals x, the simplest linear function, if you will, and then talk with our students about how well that models our data and how we could maybe change it to model our data better. So here's where, instead of graphing a stat plot, we're actually going to graph a function. And so to do that, we'll go over to our y equals screen. So I'll push y equals. Lots of function entry lines here, so we can graph lots of things. You'll also notice while we're on the screen that plot 1 is highlighted. That's telling us that our stat plot 1 is turned on while our others are turned off. That makes sense because we already went into our second stat plot setting and turned that on. So I want to leave that on, but meanwhile I want to add another function here. So I'm just going to graph the line y equals x by pushing the x variable here. And then I'll go back to my graph. Oh, and I really don't want those both to be blue. So I'll go back to y equals. That's just a little thing driving me crazy right now. I'm going to push the left arrow, and I'm going to arrow over until the color and the line thickness there is highlighted. And now when I push enter, I can actually change those settings. So I can maybe make that color red. And if I wanted to, I can actually change the line thickness, change some shading, all kinds of things there. So that functionality is there on the TI-84 C for the color option. Let me go back to my graph. Okay, I'm happier now with that. This is also a good place to showcase another feature of this SmartView software, kind of this teaching software that I'm using. Up above, you have a number of options up here. You have a camera where you can actually take screenshots of what you're seeing here if you want to include that on an activity for class or on a quiz or a test. But what I want to showcase here is this next button with the Show, Hide, View Cube. And so when you turn that on, you'll notice that my presentation screen kind of shrunk, but I'm seeing 3 other screens as well. So I'm seeing my y equals screen, my list page, that's actually my table, and then my graph as well. So if you ever wanted to show all those at once, you can do that. You can show that or hide that with just the click of a button. So we'll see that our linear parent function y equals x does not model this function very well at all. It's not steep enough for starters. These points look like they're on a much steeper line than what we have here. So we can go back to our function, go back to the y equals screen and talk about, okay, so how do you change that? How do you change the steepness of a line? And we'll build to the idea that by changing the number or the coefficient in front of x, that will change the steepness of our line. So I just doubled that slope, made it twice as steep, but it's still not very good. So maybe I'll go back to y equals and change it to 4, double it again. So we're getting steeper, but it's still not modeling that well. And you probably know where this is going because you kind of looked at the situation to see what the equation should be. But when we go to 8x, we'll see that, okay, that looks pretty good, at least in terms of the steepness. That line kind of looks like it lines up with our data in terms of that parallelness or that steepness there. But it still doesn't model the data well because it's too far down. We kind of have to move that whole line up. And so again, we can go back to y equals and talk about that. I don't want this line to cross the y-axis here. I want it to cross somewhere higher, maybe like up around 10 maybe. So I'll go to y equals, and then we can talk about, well, how do you change that? How do you move a line up? How do you change the y-intercept? Well, that will be the part that's being added or subtracted at the end of your function. So maybe we'll try 8x plus 10 and graph that. That looks pretty close.
Michelle,
not exactly right.
Yeah, we look like we're getting really close. Is there something that we can do to tell how far off we are?
Okay, so yeah, because it looks close, but we're not exactly there. And I mean, we could guess and check. We could go back to the problem situation, but is there a way to check? So one way, and this is another feature that you'll use all the time on the 84, is to actually trace. So right next to your graph button, you have a trace button. And notice that when I push the trace button, up top it tells me what I'm tracing. So right now I'm tracing my plot 1. And if I push left and right, it's just going to jump to those blue points that are on my stat plot that I set up. If instead I want to trace my other graph, my function, I'm going to use my up and down arrows to change there. So for example, I might trace over to right underneath this point. This at 4, 42 on my function. If I jump up though and go to that point, it's at 444. And so that kind of tells us that our function, our red line, is 2 points too low, and we just need to move it up a little bit. So, but that trace functionality to move along different functions and stat plots is really handy and something that we'll use all the time to kind of check out functions. So let's go back to our y equals and just kind of fix our function here. 8x plus 12, because we said we had to go up 2 more than we were before. And now when we graph it, it should kind of, should go right through them and look pretty good. If here we wanted to check and really confirm that that function really goes through those points, we could also look at the table. Remember that we kind of used a table when we did our stat feature where we entered the data in, but I don't want a table for stat. I want a table for this whole red function and to check specific points. So right above graph, you'll see this option for table. So second table, we'll activate that. And here we can see a number of kind of different options here. Just one thing here. So we're looking at, for example, our x values here, and then their corresponding y values on the function. Tony, sorry?
Oh, Michelle, can we use the table to answer the question, the problem situation?
Okay, love that. So yeah, kind of digressed a little bit. We started with this problem where we were looking at the initial charge plus the $12 per hour, but it actually had a question in it that once we had our linear model, we wanted to be able to answer. So if the total charge is $72, how many hours did the lawn service spend mowing? So if we go back to our table, we'd have to think about, okay, what is X? This was our hours. Y1 was our cost. I think we wanted 72. And so we could kind of scroll down looking for 72. And here we're seeing 68, 76, so not our answer, but we're pretty sure it's probably somewhere in between 7 and 8 here. That kind of gives us an idea of what our solution is. We're going to come back to the table in a minute, but for just a second, we're going to go to the graph and talk about how we can use this graph to solve this problem. Remember, the standard we're looking at was all about multiple representations. How can you solve this problem in a number of different ways? So one thing we could do is we could add a line on here that was at 72, up at $72 for the cost, and then look and see where that intersects with our model. So to do that, we'll go back to y equals. I want to leave our function model, but I'll go down to the second option, type in 72. And I have to change the color because it's going to drive me crazy if they're the same. Sorry, y'all. Maybe green. And then now I'm going to graph that. So we have our original model and then this line at 72. And then now we can kind of look at and see where do these cross. We can kind of eyeball it, but we can also use that trace feature we were looking at a minute ago and trace along our function until we get close enough. Another thing I really like is sometimes it takes a while to trace. You can just jump. You can actually just type in 7. I just push the 7 button, and down at the bottom it says x equals 7. Push enter, and your tracer will jump right to that point. So here it looks like at 7.5 we actually hit $72. So that looks like that's our solution. We said we'd revisit the table, so let's go back there for a minute. Second graph to get to the table. And again, that lines up with our guess from earlier. We're kind of thinking that between 7 and 8 we would hit 72. But there's another shortcut that we love for using the table, and they give you a little reminder up here. If you press the plus sign while you're on the table, you can actually choose what your table is going up by. So I'm going to push the plus sign, and it prompts me for delta table. What do I want my steps to be on the table? So say I change this to 0.5. Now my table will go up by 0.5 increments, and there is my solution where I'm seeing that my model equaled 72, as did kind of my goal there for the cost function.
Hey, Michelle.
Yes.
We had a quick question from Jill. She wanted to know how you jumped there. a second ago.
Great question. So like how I got it to jump to 7.5?
I believe so. Jill, if you could maybe use the Q&A again and just verify that's what you were looking for.
Michelle, I think
Sure.
she might have been talking about when you did the trace.
Okay, and I can show both just in case. We'll start with maybe the graph. When I was tracing, and so for example, I'm way up here at 7.5, and I want to go all the way back to 1.5. I can just start on my merry way, clickies, but it might take a while. But the nice thing that when you're in trace is you can actually just type in the X value of where you want to jump to. So I can just type in 1.5, and as soon as I push that 1 button, a prompt came up here where it's saying, oh, that's the X you want to jump to. And then I just pushed enter, and it jumped right there. And then again, I could trace. I'm not going to be able to bring up the prompt until I just type in the next X value that I want to jump to. So that's how you can kind of jump around on the trace screen, which is really handy for kind of jumping to different places. On the table, if you want to kind of zoom in on the table, so instead of going up by halves, I want to look at this function going up by 0.1. I can just push the plus button, so that's over here on my handheld. And when I push that, it will now prompt me for delta table. What do you want your table to go up by? And I could just type in 0.1, and then now my table will go up by 0.1 increments. So it's really handy that you have that feature right on this page rather than having to go to a different page to do that. Great questions. If there's any others or y'all are wondering things or have thoughts, please feel free to share them in a chat or the Q&A, and Mike and Tony will give voice to them. Other things?
Michelle, can we go back and do it a different way and clear out our Y1 and our Y2 and talk about manual fit?
Okay. Yeah, manual fit's kind of a lesser known thing, but kind of cool. So let's look at that. So I'm clearing out the model that we made. And if I go back to graph, so I just have my points. Okay, so manual fit is another way that we can come up with a model or have students come up with a model. This is another one that's a little bit hidden. We have to kind of hunt for it, but once you've done it a couple times, it'll be a little bit more familiar. This one's actually hidden under the stat menu. So if you push stat, and then if we went to edit, that's actually where we put our data in before. So we're not going there. Instead, we're going over to calc. And what we want, there's all kinds of options here. Most of them are not going to be applicable for 8th grade math. The one we want is at the very bottom. So we can scroll down all the way through, or we can kind of do a shortcut and scroll up, and it'll take us to the bottom. We want the second last one, I'm sorry. So option D will be manual fit y equals mx plus b. So this will allow us to manually fit a line onto our points and kind of come up with an equation. So I'm going to push enter to select that. Now, we want to store our equation somewhere so that we have it handy. And it makes sense that we want to store it kind of in Y1, but we don't want it to type it in. We want the calculator to save it there. So one of the new shortcuts that came into play with the new operating system is if you push alpha and then trace, you'll have access to all of your Y's, if you will, with just the touch of a button. And so if you have an 84 and you do alpha trace and this doesn't pop up, that may mean that your operating system hasn't been updated, but that's a quick fix. So for right now, I just want Y1, so I'm going to push enter, and you'll see that just like that, it populates it with Y1. Then I'll go down to calculate. Now, let's just kind of look at what's going on here. We have our graph page here, and then I have this little cursor. And so what I'm going to be able to do now is move the cursor around using my touchpad. And I'm going to drop points on my graph. So I'm going to hover over that uppermost point and push enter. And then I'm going to kind of arrow left and right. It takes a little bit longer when you're using the computer mouse than if you're doing this actually with a handheld. So I may only go for this point here instead of going all the way. But I'm going to line this up with maybe that last point and then that middle point. And push enter. And so as soon as I put those 2 points in, now it's come up with a function model, a manual fit, if you will, using y equals mx plus b, which you see up here. So that's kind of close to what we had before, 8.03x plus 11.8-ish. We can look at the table, but another thing is this is highlighted right now. So while it's highlighted, I can actually make changes to it. So I might look back at the problem situation and say, it probably wasn't 8.03, it probably was 8. And as soon as I typed 8, you'll see that it prompted me for M, the slope. I'll push enter. It changed that for me. I think I can arrow over and do this. I can arrow over and do the same thing here with the y-intercept. Maybe change that to 12. Push enter. And then now I have a model that I'm really happy with, but that also kind of matches the context of the problem. And then when I'm done, you'll see done over here on my screen, or here right above graph, I can push graph to kind of finalize my model. And then it'll kind of put it on the graph page. But also when I go to y equals, it saves that model to y1 because that's where I asked the calculator to put that specific model. So thank you, Tony, for reminding me about that, because that's a really neat feature for modeling as well that I hadn't thought of. Other questions or comments?
Michelle, we actually had a question from Nancy. And I'm trying to get a little more information so I can understand her question a little bit better, but maybe you might be able to figure this out. She said she missed the part on how you go to STAAR. And she said she got lost after we went to second calc.
Sure. Okay, so what I'm thinking is in the stat menu, okay, so when we're doing our manual fit, we went to stat, over to our calc menu, and then we wanted one of the bottommost options, so I went up, and up one more time to get to manual fit. It's probably right on this screen when she's asking where do you, when it's asking where do you store the equation. So here's the trick though. We weren't actually doing second trace, we did alpha trace, which is a shortcut to get us to all the y's of where we wanted our equation to be stored. And those alpha shortcuts are new with the new operating system, and they're really hidden. You kind of have to know that they're there as shortcuts. So that's where I went alpha trace to get y1, and that was just a shortcut to get that little icon there. And then I went down to calculate. So that might have been the kind of the wrong turn there. Good question. And then it would take me back to the screen where I can trace my points or whatnot. So kind of quit out of there. Oh, I know, it's mad now. Okay, so feel free to share other questions or comments as they come up. We're going to segue a little bit away from linear functions. We talked about a lot there. We talked about how you can enter points into a list, how you can use your stat plot to graph those as points on a graph, how you can go to y equals to enter them as equations, and then how you can use that manual fit option as well. We also looked at the table some, so all kinds of things kind of going on in this one linear function idea. But the 84 can do so much more than this, and so I wanted to kind of transition a little bit into how you can use the 84 for all kinds of calculations. So to get to my kind of calculate page, I'm going to go to second and then mode, which will quit. So second quit will take me to kind of a blank page where I can do some calculations. And so we'd love to get some ideas from y'all here. So our question kind of is, what are some sorts of calculations that your students do currently in 8th grade math or will do next year in 8th grade math? So if you'll take a minute and go over to the chat screen and send your chat to all participants and just share with us one or two calculations that your students would do in 8th grade that you'd like to see modeled here. So we'll give you a minute or two to share some of those, and then we'll work through what they would look like on the 84.
Michelle?
Yes, ma'am.
So while people are typing in their ideas, can we start by adding two rational numbers?
Okay, that's a good one. So, like, say we want to do something like a half plus a third, something like that.
Sounds great.
Okay, so a couple ways that we can do that. And again, please feel free to share the other things you're thinking about in the chat section as well, because we want to share lots of different calculations here. So say we're just going to do 1/2, 1 divided by 2, plus 1 divided by 3. So I'm just entering those kind of using the division symbol, and I'll push enter to run that calculation. So we'll see that a couple things about this. I entered them as fractions, but they kind of came out as slanty fractions, which I'm not thrilled about. I kind of want them to look like how I would write them on paper, 1/2 plus 1/3. And then also you'll notice that my answer came out as a decimal, and I really wanted it as a fraction. So let me show you another way you can run that same kind of calculation. Another one of the hidden new features, okay? So we're going to push alpha again, but instead of pushing trace, which gave us our y1, y2, y3, push alpha and then y equals. When I push that, I'm bringing up kind of a secret fraction menu where I've got a fraction and then a mixed fraction, and then the third line is kind of converting between the two, and this fourth line is actually converting from a fraction to a decimal. So right now we're just going to check out this very first one, number 1. So I'll just push enter. When I do that, I now get a stacked fraction template that I can just type into. So now my 1/2 looks like the 1/2 that it would look like if I wrote it by hand. So I'm going to do 1/2 plus, go get another stacked fraction template. So again, those are hidden under alpha y equals. The very first option, 1/3. So let's run the calculation this way. Push enter. So a couple interesting things. Now I now have my stacked fractions that look mathematically correct, like we read them by hand, if you will. And then also my answer comes out as a fraction. So I'm actually seeing it as 5/6, which is interesting. So just a couple things to notice there.
Michelle?
Okay, so what is, yes ma'am.
What if we wanted to just change one of those two and we didn't want to retype the whole thing? How can we do that?
Okay, so I don't want to have to go get more fraction templates. I just want to make one change to this. Okay, so another great feature is that you actually kind of have the ability to scroll through your history. And so I'm going to use my up arrow, and when I push up, I can scroll through all of my different previous entries, if you will. So I'm going to scroll to maybe this option, and with it highlighted, I'll push enter. And when I do that, it actually copies it down to the current line that I'm in. And then once I have it copied down, I can arrow over into any part of this, make a quick change, and then run that new computation. And so that's pretty handy, especially if you have a complex computation that you have going on where you don't want to have to retype everything, you just want to make a quick change. You can just scroll up through your history, and then whatever's highlighted, you can push enter to bring it down to your current line. Great question.
Michelle, if we can clarify, when you're going up to get those templates, you're using the alpha, which is in green, and then you're actually pushing F1 because that's also in green. So it's the F1, F2, F3. Those give you those screens that came with the update that give you those shortcut screens.
Okay, that's a great, thank you for saying that. That's a great comment. Yes, the alpha, that green button, runs the green functions here. So alpha F1, oops, I messed it up, sorry. Alpha and then F1 actually brings up this hidden fraction template. It doesn't say fraction right here, it just says F1. And then alpha F2 brings up kind of a hidden function template. And then alpha F3, we have some matrix operations, not really 8th grade stuff, but just good to know it's there. And then alpha F4 brings up those y variables that I used earlier to store my equation really quickly. So thank you. One that you'll use a bunch is alpha F1 to get all those different fraction templates that we'll use in the middle school. That's a great clarification. Thank you, Tony. Okay, other calculations or that we can do.
What about finding the volume of a sphere? Can you model that calculation?
Okay, so that's a good one. And so we'd be looking at, like, I think the equation is volume is 4/3 pi r cubed. And so how would we want students to type that in? And so we may want them to actually use a fraction template again. So we go alpha F1 to bring up the fraction template. I want the very first one. I can enter in my 4 cubed. I need my pi button now. So kind of looking around here, I'll see it in blue up above the caret, and so second caret will bring up pi. And then say we had a sphere of radius 5. So I may enter 5. And then to put a cube on that, now I'll use the caret without the second, just the caret. And you'll notice that when you push that caret, it actually moves the cursor up into the exponent position. And so then you can put kind of your cube, if you will, where it belongs. And so this is really kind of showing the math print that's been included in the 84 with the new update and how nicely that looks, because it really looks like what students would write by hand. And then we'll push enter to run that calculation, and it'll give me the volume of that particular sphere. Good one. Other calculations to model?
Yes. Michelle, we have from Claire, can we see a quadratic parent function and finding the vertex or the min or the max?
Sure. So while that's not specific to 8th grade, absolutely, that's something that would show up more in Algebra 1 or Algebra 2. But we're going back to the graph screen for this. And so I'll maybe clear out the function I had there before. I'm also going to go up to plot 1 and just push enter to unhighlight that. And so now my graph will be blank, and I just want to graph y equals x squared, so kind of the quadratic parent function as you mentioned. So my quickest way to do square is right here with this button, so x squared. And you'll notice again we've got math print where it shows the square kind of in that exponent position. And I'll push graph. Now we have our window set up for our previous function. So I may want to change that back to kind of a standard window. Fastest way to do that would actually be through the zoom button, which we hadn't talked about yet. So this is a great question. We'll go to zoom, and there's a number of zoom options. But just to make it easy for what we're looking at here, we're just going to go to the standard zoom, see what we got going on. So there's our kind of -10 to 10, -10 to 10, and there's our quadratic parent function. So if we wanted to find the minimum value, we could trace along it like we were doing before with the trace button. But right above the trace button, there's a number of things that you can calculate on the graph. So I'm going to push second calc. And when I do that, I can find a value, a 0, a max, a min. While I'm here, I want to mention the intersect command, because this is critical for now for 8th grade, where you'll be solving systems of equations by graphing only. So you'll actually graph 2 lines in y1 and y2, and then you can use the intersect command to find where those 2 cross. That command is going to look a lot like the one we're going to use now. So I'm going to go down to number 3 for minimum. And I'm kind of going to be prompted through this. So left bound, what it's asking for here is be on the left of where that minimum is. So I'm over, I know the minimum's kind of around here-ish. I am definitely on the left side of where that min is. So I'm going to push enter. And then it's asking for the right bound. So I'm going to scroll over till I'm definitely on the right side of where that minimum is. Oh yeah, I'm on my way up. I'm past it. Push enter. Then it's going to ask for a guess. I could push enter right now, but I'm going to kind of go get close to it. So maybe around here. And push enter. And once you kind of complete those 3 prompts, it will bring you up, it'll bring up the min that you're seeing here. This one might be one we need to translate with our students. What does this notation mean? And it's really interesting that it's rounding to those specifically. This is really close to 0. This is even closer to 0. This may be one where I'd want to then trace with my students and have them check that that point is actually 0, 0. Those are really weird approximations. So great question there. One other thing I want to mention on calculator page, and we'll see if there's other calculations you want to discuss or model as well. One of the other new standards that we see in 8th grade, moving down from Algebra 1 in Texas, is this idea of calculating slope from similar right triangles and using the slope formula, as you kind of see it here, y2 minus y1 divided by x2 minus x1 for any 2 given points on the same line. So we kind of have 2 sample points here, -1, -6, 5, -3. Say our students had to calculate the slope between those 2 points. So we'll go back to our 84. Now here's where I want to start. I want my students to be able to use this fraction template, alpha S1, and then the first option, so that when they type in their Y2, which in our case was -3, then they can minus or subtract their Y1, -6, go down to their denominator, start with their X2, 5, minus our X1, -1. And it's going to look like in the calculator what they would type by hand. So I'll push enter, kind of run that through. And here's why I say this. Without using this template, I would have some students who would enter the calculation like this. -3 minus -6 divided by 5 minus -1. And in their mind, you know, this is all in the numerator, this is all in the denominator, so this should give us the same thing as what I'm writing by hand. And we know from order of operations that that doesn't work, that it's actually kind of going to do the division first and then the other pieces. And so I think having this ability to use that fraction template is really a powerful thing. Tony, what else do you want to show?
I don't have anything else. I'm checking the chat real quick.
Okay. While you do that, I will talk about ordering rational numbers. So for example, we have this standard, which has been in 8th grade in Texas for a long time, order a set of real numbers, but now we have the calculator to help us. So of course, we could take two fractions like maybe 5/6 and 7/8 and order those in a number of different ways. We could enter them in here into the calculator and get decimal approximations and order those. But I wanted to show you another kind of shortcut that's really pretty neat. We're going to enter the first one as a fraction using a template. So let me do alpha S1, get that fraction template, enter 5/6. You can also use Boolean logic to test to see if statements are true. So what I want to ask the calculator is 5/6 less than 7/8, for example? So let's see here. I think it's under second math. There's a test button here. If I go to second math, I actually have all of my equals, not equal to, and then inequality symbols. So I want to go down to number 5, less than. And so now I've typed in 5/6 is less than 7/8, and I'll push enter. So this is something where we need to know what the output means. When the calculator outputs 1 here, that is telling us that this statement that we've entered is true. So if I go back to that statement, copy it down again, and this time I'm going to go over to the less than symbol and change it. So again, I got that symbol from second math in the test menu. This time I'm going to change it to greater than. Is 5/6 greater than 7/8? And push enter. And we'll get a 0 because that statement is false. And so this ability to test different inequalities for ordering numbers, you can also test solutions to equations this way, as long as you understand the output that's coming out and what it's really telling you. Okay, we'll still be glad to take any kind of questions in the chat and Q&A, but I want to change gears just a little bit and just share some resources that are available free online. So one of my favorite sites is the TI Math site, where you can go and find pre-made, ready-made activities, both for the Nspire, as you're seeing here, but also for the 84, what we've been looking at, for all these different subject areas. So one such activity, this is one that currently is coded under Algebra 1, because it's an Algebra 1 standard in a lot of states, but in Texas it's moved down to 8th grade. And that's the idea of solving systems of equations by graphing. So this particular activity, it comes with teacher notes, a student activity in doc and PDF forms. I'll show you what that kind of looks like. So here's the student activity, and it walks students through what they can do on their handheld to explore two sets of systems. So it has kind of keystrokes as well as functions to enter, specific window settings it wants students to look at, and then talks about, okay, so what is the solution to the system? How can you see it from the graph? How can you find it using trace? What does it mean that the point 87 is on both functions? What does that mean? And so really developing this idea of what is a solution to a system graphically, which again is one of our new 8th grade standards. So what I love about these pre-made activities is they are pre-made and they're free, and TI also releases them, kind of as we're seeing here, in PDF version and a doc version. So with that doc version, you can download it, make changes, add different questions, that kind of stuff to really personalize it for your students. So we wanted to share the TI Math site because it has all kinds of great resources that are ready-made for you to use in your classroom. And those resources also come with teacher notes, which have answers to the different questions, but also different prompts and ways that you can think about presenting that activity as well. Okay, Tony, anything else you want to share before we fix to wrap up?
No, I think that's great. Thank you, Michelle.
Okay, well, we'll switch back over to Mike at this point, but please feel free to share other questions or comments in the chat and Q&A, and Tony and I will be happy to answer those.
Thanks so much. So we are going to begin wrapping things up, and I know Michelle and Tony just went through a couple of resources that are available on our website, and I do want to show you another additional resource because I think it's an important one. And so let me share my desktop. And if you go to our website, education.ti.com, and you still have a question or you'd like possibly a demonstration with some of the technology that you saw tonight, if you go to our website on any page and you scroll all the way to the bottom and find Contact TI, and on the left-hand side you'll see TI Sales Support. If you click on that link, and especially if you are in Texas, I know we have Rob Wilson on tonight, and I know Rob is really big on helping his teachers use technology appropriately in the classroom, and so he's really a great intermediate in between you in the classroom and what you might need from Texas Instruments. So if you'd like more information or possibly a demonstration, I know he would be more than happy to talk to you. But listed also are the other partnership development consultants, depending on what region you're from, because I know we have some people that are not from Texas on tonight. Also, I know, I think Wayne earlier gave a shout out to Atomic Learning, and so I just want to show you where those resources are. Under the Professional Development tab, if you move down to Online Learning, and then Tutorials. And then in the middle you have Graphing Tutorials, and this will get you tutorials for the TI-83 and TI-84 Plus. And what I really like about these are free short videos that just give you tutorials on how to use your TI-83 and 84. So in case there's a skill that you haven't seen in a while, it's a great way to brush up your skills or maybe learn new skills as well. And I know, I think Michelle and Tony both mentioned that we do have some T-Cube summer workshops occurring across the United States, but also specifically in Texas this summer, and they focus on the TEKS. Michelle, I think you might be actually hosting one of those. So would you mind sharing with us just really briefly if someone expects to sign up for a summer workshop, especially in Texas, what they could expect to see?
Yes, we are so excited about these summer workshops because they will help you over 3 days. Some are 1- and 2-day options as well. Really get immersed in this new technology, but they're all based on the new standards. There's middle school versions as well as high school versions. They're based on the Texas standards, and we specifically chose activities that would help address those tough-to-teach standards or those brand new standards where we wonder, what is that going to look like? And so it's kind of you get double for your money, if you will, in terms of you get great PD with the graphing calculator technology, but you also get to learn about how it helps support those new standards that we have coming out in Texas. So we're really excited about those. I'm hosting one in Midland, as you see up here, and there's some other options across the state as well. We'd love to see y'all at any of those.
Thanks so much, Michelle. So I think it's time to do some thanks. And so let's skip ahead here. There we go. So thank you so much, Michelle and Tony, for all the work that you did to prepare for tonight. There's a lot of great information shared and some great questions that were asked and answered. And so I really hope that everyone got something they can take away from this webinar tonight. So Michelle and Tony, thank you so much.
Thank you, Mike. It's a pleasure being here.
Thanks. To receive a certificate of attendance, go ahead and click that link in the chat window, and that link will direct you to the certificate of attendance, which does contain a name, date, and duration of tonight's event. Also listed, there was a link for the documents that were used tonight by Michelle and Tony. And if you seem to miss that, no big deal. You'll get a follow-up email in a couple days from us that will have a link to the recording, as well as a link to the documents and the certificate of attendance. So if you'd like to share this recording with some of your colleagues, please feel free to do so. But again, thank you so much for joining us tonight, and we really hope to see you back online soon. Thanks so much.